Okay, good evening. Today we are going to discuss about measuring instrument, the rest of equipments. Hi. Before that, may I have to tell you one thing. Actually, I think last week, in the last week, I have sent you some one poll, no? Whether you come to the live classes or whether you are going to watching recordings. I think according to your votes, I think as I remember, actually there were only 3 students and there were only 3 students who are going to watch recordings only. All the others willing to participate for the live classes. Therefore, if anyone absent, or if you suppose if I'm going to absent for a particular class, so please let me know that one. So that practice should be there for take. Class in නැත්නම් පොඩ්ඩක් මාව එකට acknowledge කරන්න. ඒ practice එක තියාගන්න. මොකද එහෙම කරලා ඔයගොල්ලන්ගේ recording එක ඔයගොල්ලෝ ඉල්ල ගන්න. හරිද? Okay. මොකද මම දැන් class එක කරද්දි මම බලන් ඉන්නවා දැන් කට්ටියන එක. හරිද? එතකොට අපි time එක තමයි අපිට යන්නේ. හරිද? මම වඩා කැමතියි අපි 8:30 නම් 8:30 පටන් ගන්න. 2 නම් 2 පටන් ගන්න මම වඩා කැමතියි ඒ නිසා හැමෝම කන්සර්න් වෙන්න punctual තියාගන්න. Okay. Shall we start? Okay. Last time we have discussed about screw principle. Screw principle. Please let me know. Please let me give 1 minute. Okay. Okay. As we discussed earlier, this is the micrometer screw gauge. Actually, we have discussed the screw principle and what is the least count of screw principle and what's the mechanism of micrometer screw gauge. And we have named that instrument and actually we have discussed how to take a measurement using a micrometer screw gauge. Okay. Today we are going to discuss about the zero error and how to get a practical measurement or how to answer questions in micrometer screw gauge. And so those are the things we are going to discuss today. So after completing micrometer screw gauge, we will move into the next part, that is spherometer. Okay. As you know, here there's a zero mark. Okay. So if you want to move the thimble into the right hand direction, you have to rotate the micrometer screw gauge into the downward direction. Okay. You have to remember that thing. So if you want to move this part into the right hand direction, you should rotate the micrometer screw gauge into the downward direction. When you are rotating the micrometer screw gauge or thimble into the downward direction, this will open. If you want to close that one, you have to rotate the thimble into the upward direction. So if you rotate the thimble into the upward direction, this will close. So, or if you rotate the thimble into downward direction, it will open. So normally, when you are taking a measurement, you have to open the micrometer screw gauge. That means you have to rotate the thimble into the downward direction. you have to make this is very, very important part, okay? You have to remember this one, okay? How to open the gap, how to open the gap in between and middle and spindle, how to open the gap. You have to rotate the spindle into the downward direction, into the downward direction. And, okay, so when you are taking measurements or when you are uh, taking zero error, you have to remember that people. Okay. As in the other equipments, micrometer is true. Actually, we have discussed in vernier caliper. There can be a zero error. Zero error means the vernier zero. If the vernier zero is not coincide with the main scale zero, then that error is called the zero error. The same kind of error can be happen or can be occurred in micrometer screw gauge. That means if you cross this gap between anvil and spindle, the zero level, the zero mark of the circular scale and the zero mark of the linear scale should be coincide. Should be coincide. If not, definitely there will be a reading. There will be a reading. Okay. So that reading will be affected to the final reading. Therefore, that will be an error. That error is called as zero error, as in the previous case for it. So as we mentioned in the vernier caliper, we call this error as a zero error because when we cross the micrometer screw gauge, the zero marks are not coincide. And okay. So if they are not coincide, definitely there will be a reading. That reading will be a positive reading or negative reading according to the place where the zero mark is located. And, shall we discuss that thing? Then write a topic. Zero error. Zero error. And I'm not going to give a note today because that note is in the book. Therefore, I will explain that thing, but you have to mention the topic and draw the figures in the book. And all the explanations are in the tute. Okay. As I mentioned you, if you want the hard copies of tute, please let me know. Especially this is for the newcomers. So I'm going to submit those. Actually, I'm going to post these tutes, I think, in this Thursday. So I can post these tutes in this Thursday. So before that, you have to give me the addresses. Okay. Zero error. Okay. As you know, please listen to me very carefully. As you know, if you want to open this gap, you have to rotate the thimble into the downward direction. That means if the thimble is rotated into downward direction, definitely there should be a reading. There should be a already reading, no? Okay. Now, this is the linear scale. This is the circular scale. So, if there's no zero error, zero mark of the circular scale should be coincide with the zero mark of the linear scale. This is the zero mark of the linear scale. This is the zero mark of the uh, circular scale. Okay. If there's no zero error, then the arrangement should be like this. No zero error. So this is this instance. No zero error. Suppose if the thimble, so this assemble is connected to thimble. So if the thimble is rotated in downward direction, then the zero mark of the circular scale will be shifted into the downward direction. Will be shifted into downward direction. Then the arrangement will be like this. You see the zero mark. Like this. So if so when you cross the micrometer screw gauge, when you cross the micrometer screw gauge, suppose your arrangement is like this. If your arrangement is like this, that means the thimble is already rotated into downward direction. The thimble is already rotated in downward direction. That means this screw gauge now has a reading with it. It has a reading. Or this is a zero error, and this should be a positive zero error. Yes, so this is a neutral. This is a neutral. And as well as this is a positive zero error. Why? If it is a positive zero error, there should be already reading for it. There should be already reading. In vernier caliper, if there is a reading, if there's already reading, the vernier scale should be shifted to the right hand direction. And if the vernier scale is shifted to the right hand direction, then there's already reading. If there's already reading, that kind of error is called as positive zero error. Therefore, this is a positive zero error because now there's a already reading in the micrometer screw gauge. This thimble is shifted in the thimble is rotated, actually not rotated, but thimble is placed as it is rotated into the downward direction. And therefore, this micrometer screw gauge has a reading now. That reading is equal to the 0.12, 0.02 millimeters. Has 0.02 millimeters because the second mark is overlapped with the zero mark. Therefore, you have to multiply 2 by the least count. Suppose the least count is 0.01. Therefore, now reading is 2 into 0.01. That means 0.02. Now this reading is already in the micrometer screw gauge. Therefore, this kind of zero error, this is a zero error. This kind of zero error is called a positive zero error. This is a positive zero error. positive zero error. Reading is already in the instrument. So if there's a positive zero error, you have to subtract that value from the actual reading. You have to subtract that value from the actual reading. And therefore, actual reading is equal to the reading minus error. Reading minus error. Got it? Did you get my explanation? Thermal explanation. I make a minus to make the I need responses from everyone.
Yes, sir.
Thank you. Very good. Others? Thank you. Now, so this is called as a positive zero error. This is called as a positive zero error. මේක උඩින් දාගත්තා නම් ලේසියි. එතකොට පැහැදිලි. මේක no zero error. මේක positive zero error. Okay. Suppose once the anvil and spindle are touched. Okay. Once the anvil and spindle are touched, suppose if the zero mark is rotated or is located beyond this horizontal line, above the horizontal line, then what will happen? That means it is moved into the anvil. And that means the circular scale now is behind the actual position. Now it is behind the actual position. So if it is in the actual position, definitely the 20 mark should be overlap. They should be overlap. If the 0 mark is above the horizontal line, that means this one is shifted into the left-hand side. That means thimble is shifted to the left-hand side. If the thimble is shifted to the left-hand side, that means it is behind the actual reading. It is behind the actual reading. And therefore, it is a zero error. That kind of zero error is called as negative zero error. Negative zero error because that error is behind the actual error. It is behind the actual error. That is the reason it is called as a negative zero error. So if it is a negative zero error, then the error should be like this. So zero mark. The zero mark of the linear scale should be inside the vernier scale. Now it should be inside the vernier scale because now not vernier scale, circular scale. The zero mark of the linear scale now should be inside the circular scale because the circular scale is the circular scale passes the zero line. zero line. Now it is behind the zero line. It is behind the zero line. Therefore, zero mark should be inside the circular scale project. That cannot be seen. Linear scale එක zero mark එකකුත් දැන් අපිට බලා ගන්න බෑ. පේන්නේ. හරිද? එයා ඇතුළේ ඉන්නේ. හරි? නෑ කටට හිතන්නේ. ඊළඟට හොඳට මතක තියාගන්න ඕනේ, you have to remember this one very carefully. If you consider about 0 point, if you consider about 0 point, the below the 0 point, there will be 45, 40, 35 like this. The above the 0 point, there will be 5, 10, 15 like that. And therefore, below the 0 point, the radius should be subtract by the 50 rupees. And then කොච්චර shift වෙනවද කියලා බලන්න එපා. කොච්චර shift වෙනවද බලන්න. මෙතන තිබ්බේ 0 point එක වෙන්න මෙතන තිබ්බේ. නේ? Initially 0 point එක මෙතන තිබ්බේ. Initially the 0 point was at this location. Now it is shifted by this much of distance. This much of distance. Okay. Therefore, you have to count the shifted distance. You have to count the shifted distance. How to count that one? You can count from 1, 2, 3, from 0 to this point. You can count from 0 to this point. Or otherwise, you can take that value. That value is 47. You put it. That value is 45, 46, 47. 47, you can subtract that 47 by 50 and take it as 3. The shifted number of divisions. Is equal to 3. But the thing is, the most easiest way is you can count that one. Yes, normally in a standard macrometer screw gauge, the number of divisions in this circular scale is 50, and the number of divisions in the circular scale is 50. That is a standard configuration. And otherwise, it should be given. So if they not mention that one, that means it is a standard mathematics screw gauge. And but the thing is, in most of the questions, that is mentioned. Because otherwise, the students cannot be justified what is the correct answer. And therefore, if you are given that kind of question, it will be mentioned. But in case, if it is not mentioned, please take it as a standard mathematics screw gauge. So the number of divisions shifted, the initial zero mark, the 0 mark was at this position. Initially, the 0 mark was at this position. Now it is at this position. That means it is shifted 1, 2, 3 division. It is shifted 1, 2, 3 division. Therefore, from that, you can determine the distance it is moved. The distance moved. You can determine the distance. So that is equal to the number of divisions into the least count. Number of division is the into the least count. Okay. Then I can write reading is equal number of divisions to 3 into 0.01. That means 0.03 millimeter. This is into the left hand side. This is into the left hand side. This is into the left hand side. Therefore, the actual reading is behind the observed reading. And not the sorry, here. And therefore the observed reading is behind the actual reading. And having මොකද දැන් මෙයා ඉන්න පස්සේ පුතේ මෙයා ඉන්න දැන් අත්තරම මේක ඉන්නවනේ මෙතන අත්තරම මේ circular scale දිනන මෙතන හරිද the actually the circular scale should be at this location. Now it is shifted into the left hand side. That means the observed value is behind the actual value. Because reading is behind the actual zero. Therefore, observed reading is behind the actual reading. Behind the actual reading. Therefore, if you want to find the actual reading, that is equal to the reading plus error. Reading plus error. Here reading plus error. Here reading minus error. Okay. So this one is called as negative zero error. Negative zero error. Negative zero error because the actual reading is behind the observed reading is behind the actual one. And again, then අපි observe කරන reading එක අඩුයි. හේතුව මෙයා ඇතුළේ ඉඳන් ඉන්නේ. Did you get my point? පැහැදිලිද මේ explanation එක?
Yes, sir.
Did you get my? Thank you. Okay. Now you can write the zero error. Now you can write the topic zero error. Then you can simply mention those things. Actually, I'm not going to give a descriptive note because that is in the tutor. Okay. Quickly write this one. Quickly. Okay. Then shall we do some examples? I think you can do the tutor. Okay. Shall we go through the tut? I will share. Okay. This is a theory note, okay? This is theory note. Here, no zero, positive zero error, and negative zero error. Okay. All right. Look at this one. Look at this one. Okay. Can you see this? Everyone, I need the responses. Can you see this?
Yes, sir.
Thank you. Okay. Look at this first figure. बाद में पहले figure का. Wait a minute. Look at this one. Okay. Here there's no zero. No zero error there. Look at the second figure. Look at the second figure. So how to read this one? कौन मम्मी का मैं read करा बना? How to read this one? You can clearly see up to this level, 5 millimeters there. Then, one minute, 6, 7, 8 में 6, 7, 8 होते. Okay. The upper readings, those are the upper readings. The below readings are 0.5 readings. 0.5 reading. Therefore, this reading is 5.5, 6.5, 7.5, 8.5. Therefore, you can read up to 8.5 here. So that is the maximum readable length in the linear scale routine. Therefore, maximum readable length is equal to 8.5. 8.5. Okay. So you have to add the circular reading to the 8.5. You have to add the circular reading to the 8.5. The circular reading is 0.4 today. Therefore, 0.4 into 0.01 means 0.4. Therefore, you have to add 8.5 to 0.4. Therefore, reading is 8.9. Therefore, reading is 8.9. Did you get my point? 8.9 आया कौन दिया? Same ना 8.9 आया कौन दिया?
Yeah, sir.
Okay, thank you. This one. 8.5 plus 0.4. 0.4. Here there's 8.5 होते 8.5. बढ़ाने दे. Fine. Now the second row. Second row. Now, so the first row there's no zero error. The second row, now it has a positive zero error. No, it has a positive zero error. So once the micrometer storage is closed, the zero mark, of the linear scale here, vernier scale is here. Therefore, vernier scale is shifted into the downward direction. It is shifted into downward direction means it is a positive zero error. It is a positive zero error. Now you have to calculate the zero error. Count down. Count this. 1, 2, 3. 1, 2, 3. That means zero error is, so the number of divisions shifted. Number of divisions shifted is equal to 3. So you have to multiply that one by the least count. So least count is 0 0.01, 0 0.01. Number of division shifted. Number of division shifted is 3. Therefore, the reading is 0.03 reading. This is a positive zero error. Therefore, we can take it as positive 0.03. Now, you can look at the reading. Now, you can look at the reading of this vernier caliper. What do you caliper? Micrometer gauge. But reading. Look at the reading. Reading. Look at this one. Here 5 with 8, 6, 7, 8. Now 8 here, 8.5 here, 8.5 here, 8.5. That is the maximum possible reading in the linear scale. Then the coincide mark is 41, 42, 43. 43 put it. That means 0.43. 0.43. Because 43 should be multiplied by the least count. Least count is 0.01. So once you multiply 43 by 0.01, the answer is 0.43. Therefore, your reading is 8.93. 8.93. Your reading is 8.93. But the thing is, this screw gauge had a zero error, positive zero error. So you have to subtract that value from the actual reading. So this is a reading, Pute. So to take the actual reading, you have to subtract. We have to subtract the zero error. Zero error is 0.03. Therefore, answer is 8.9. 8.990. 8.96. Okay. Did you get my point? පැහැදිලිද ඒක? කොහොමද ආවේ කියලා? තේරෙයිද?
Yes, sir.
Thank you. Okay. Then the third one. Third one. In the third one, you can clearly see now the zero mark of the linear scale is inside the circular scale. That means circular scale is shifted into the left-hand side. Into the left-hand side. That means now the reading is behind the zero mark. So this is a negative zero error. This is a negative zero error. So first you have to calculate the zero error. Then you have to add that value to the observed reading to take the actual one. All right. So in this case, 1, 2, 3, third division is coincide with this horizontal mark. That means the zero error is equal to 3 into 0.01 least count. Therefore, this one is equal to 0.03. But in this case, this is a minus 0, minus 0. And but my advice is don't put plus and minus here. Don't put that mark, because if you put that mark, sometimes you can subtract that value from the reading. If you subtract that value from the reading, it is wrong. You have add that thing. Therefore, don't put plus and minus marks if it is not mentioned. And write down that one. Positive 0 error, negative 0 error. And you can write in word. That is much better. That is much better, because if you write it as for a plus and minus mark, sometimes you might add that value or subtract that value from the observed reading, and then your answer will be wrong. Therefore, my advice is do not put any sign in front of this 0 error mark. You can write it in words. That is much better. මොහොත් ලියන්න නැතුව ඉන්න එපා. හැබැයි වචනෙන් ලියන්න එක ලේසි. Now we have calculated the 0 error පුතේ. Then the reading. බලන්න reading එක. Okay, it is very clear now. Initial reading is 8.5, 8.5 plus 35, 36, 37 plus 37. Me 1, 36, 37. That means 0.37. It is the reading in the circular scale. How to take that one? How to take this one? The number of division overlap is 37. 37 should be multiplied with the least count 0.01. 0.01. Therefore, reading is this one. Therefore, entire reading is 8.5 plus 0.37. That means 8.86, 87, 8.87. 8.87. So you have to subtract. Sorry. Now this is a negative 0 error. So you have to add that value to the reading. Therefore, 0 error is 0.03. So you have to add that value into the. You have to add that value into the reading. That means your answer is 8.9. Here your answer is 8.9. And did you get my explanation? There? Here.
Yes. Understand, sir.
Okay. Now you can start to do the Pute. The first question. The following micrometer screw gauges have their jaws closed firmly, but the readings are not exactly 0. Determine 0 error and whether it is positive or negative. There are 1, 2, 3, 4, 6. There are 6 questions here. Tagala questions. Hi, Karan. It is better to draw. But I think you are given this method. You are given this tube. Therefore, you can give the answer in that tube. හරිද? ඒ කියන්නේ දැන් ඕනනම් ඔයගොල්ලෝ මේක ඩ්‍රෝ කරන්න නැතුව ලියලා හැබැයි ටියුට් එක හම්බ වුණාට පස්සේ ටියුට් එක ටික ෆිල් කරගන්න. ටියුට් එක ටික ෆිල් කරගන්න. එහෙම කරන්න. ඒක කවන්න නැත්නම් හන්දත් කමන්නේ දැන් ඉතින්. ටක් ගාලා. දෙකෙන් එකක්.
Up to D done, sir.
Sorry?
Up to D done, sir. Up to fourth one.
True. Fourth one, no? Hurry. Do the E and A. Okay. Shall we discuss? First one. Look at this one. Is this positive or negative zero error?
Positive, sir.
Positive, because zero mark is in the downside. Therefore, it is moved into downward direction. Therefore, positive. This is positive zero error. This is a positive zero error. Number of division moves. Number of division move is 1, 2, 3. 3. Therefore, this one is 0.03. 0.03. හරිද? හොඳයි. මට කියන්න බලන්න මේ ආන්සර් එක ආව කට්ටිය. ආන්සර් එක ආව කට්ටිය මට පොඩ්ඩක් සම්බන්ධයක් දාන්න. හරි.
What, sir?
කොහොමද?
What do you say, sir? I didn't.
So what is the if you had the answer, please may raise your hand. Okay, thank you. Then the next thing. B. Now tell me, is this a positive or negative zero error?
Positive, sir.
What about others? Anita? Hmm? How did you say it is positive? Now, where the zero mark? Is it in downward
Because,
direction?
because the lowest number is below the
Yeah,
line.
very good, very good. May here 20 is here, 15 is here. Therefore, the number here reduces when it goes to downward direction. Therefore, zero mark should be behind that level. Therefore, this is a positive zero error. This is a positive zero error. Therefore, this is a positive zero error. The amount of zero error is here 15, 16. That means 0.16. Zero error is 0.16. Okay. Did you get the answer?
Yes, sir.
Yes.
Thank you. Then third one. C. Tell me, is a positive or negative? C.
Negative answer.
Negative answer.
Negative. Very
Negative.
good, Pute. Thank you. All right. Now it is a negative one, no? All right. It is a negative one. All right. It is a negative one. So, if it is a negative one, What is the amount of zero error?
0.03, sir.
Yes, 0.03123 minus 0.03 minus 0.03. So yeah, actually you have to mention it as minus 4, otherwise you have to write it down, okay? In this case, it is very easy to mark plus or minus because we are not going to do calculation after that. Therefore, if this is the question only, then you can mark plus or minus, okay? D. D. Positive or negative?
Positive, sir.
Positive, sir.
Positive. Very good, Pratha, very good. Positive because the zero mark is in the downward direction. Therefore, this is positive. Zero mark is in downward direction. Therefore, this is positive. So positive. The amount
0.04, sir.
for 1, 2, 3, 4. That means 0.03. 0.04. Positive 0.04. This one. E.
So it is no zero error because
Yes,
the
sir.
zero
No
mark
zero
is
error.
coincide with the
Yes,
main.
yes. Very good, very good. F.
Positive zeroth error 0.44 millimeters.
Yes, very good. It is a positive zero error. It is a positive zero error. It should be now the zero mark is in downward direction. Zero mark is in downward direction. Okay, but zero mark means now zero mark is in downward direction and it is shifted by 44 divisions. 44 divisions. Therefore, answer should be 0.44, not 0.06. හොඳ මේක හැම වෙලේම අඩු කරන්න ඕනේ නැහැ. අඩු කරන්න ඕනේ මේක නෙගටිව් එකක්. sorry වැරදුනා. This is a negative one.
Sir, how is that possible, sir? Because the lowest number is below the.
Close. මෙයා ඉන්පත් ඉන්නේ. No. Lowest numbers yeah, this is a negative zero error. Negative one put it. Zero now zero mark is inside the when is sorry circle scale when is zero mark is inside the scale. Therefore, now the zero should be inside that mark, no? මෙහෙම නෙවෙයි පුතේ. Here 0 එකෙන් පස්සේ එන්නේ මොකද්ද? After 0 mark there is a 45 නේ පුතේ. After 0 mark 45, then 40, then 35. Likewise, no? Therefore 0 mark should be in the upward direction. Upward direction, okay? And the 0 mark in the linear scale, the 0 mark in the linear scale is actually it is inside the circular scale. It is inside the circular scale. So now it is inside the circular scale means the circular mark, that means thimble is shifted in the left hand side, not in the right hand side. If it is moving to the right hand side, definitely the zero mark should be visible. Now the zero mark is not visible anymore. Now it is in the within the circular circular path. Did you get my point, Padel?
Yeah,
Yes,
sir.
sir.
Okay. Therefore, this should be minus. This should be minus 0.06. Right? This is minus 0.06. 06, yes. Padel. Yes, listen to you are correct. Listen to you are correct. Yes, listen to you are correct. And zero mark, the zero mark, the zero mark of the linear scale is not visible here. That means the zero mark of the circular scale should be in the upward direction. Therefore, this is a negative zero error. Therefore, this is a negative zero error. Okay. Actually, when you are addressing these kind of questions, you have to have very good understanding about the scale, Kute. Especially the circular scale. In the circular scale, here 0, in upward direction here 5, downward direction here 45. And so in upward direction, after that 10, after that 40. And therefore, if you go into the upward direction, from 0 mark, the scale increases, the number increases. If you go downward direction, the number decreases. Sorry. So that means if this symbol rotates, in downward direction, you will have increment. You will have an increment in the circular scale. And but if it is moved into the upward direction, that means initially 45 here, then 40 here, then 30 here. That means the circular scale decreases. The value of the circular scale decreases. Okay. If you move into the downward direction, the value of circular scale increases. Did you get my point, Padel?
Yeah, sir.
Okay. Therefore, think very carefully. Now, we start with the second question. Tagga second question. Okay. The following meter gauges have no zero errors. There's no zero error. No zero errors. Taggal again. The second question. Okay. Shall we start discussion? Tell me
Okay,
what is the
sir.
answer? Sure. A.
What, sir?
What is the answer for question number A?
A to A, sir.
A.
A, it is 12.29.
12 point. It is not 12, Pute. It is, yes, 12, yes, 12, no, 12. Right.
That's
12.18,
12.30.
no? 12.18, no? 12.18. Right. Yes, 12. 12 point. Okay. 12.18. Then B. B.
9.49.
9 point.
49, sir.
Yes. What is the actual input there? I mean, in this case, Pute, may zero, zero error, there's no zero error. Pute. The store gauge have no zero error. Therefore, this is the actual reading. Right?
Okay, so the actual reading is 12.30, first one.
Okay. 12.81, 18, no? 12.18. This is 9.49. Yes. Here,
11.48, sir.
11 point, no. Here, 50 is here, no? 11.5 is here. 11.5 plus
11.98, sir.
98, ne? 11.98, ne? 11.98. 11.98 అది. 11.98 అది. Because 11.5 is visible, Pute. Then D. D, what is the answer? D. 12.5.
It
Yes,
is
12. Yeah, 12.5. Then E.
7.04 millimeters.
7.04. 7.04. Yes. 7.04. Yes, Pute. Yes, very good. F.
11.09 millimeters.
11 there.
15.9, sir.
15 everything.
Yes, sir, it's
15.0.
15.
15.09 everything. 15.09. G.
5.10, sir.
5. Here the how much mark here? 1, 2,
1.6 millimeters.
1, 2, 3, 4. 5.6, 6.2, 6.4, 6.6. Should accuracy. මේකේ divisions වල පොඩි කතන්දරයක් තියෙනවානේ. මෙතන තියෙන්නේ 0.5. 0.5 මෙතන 0.75. මෙතන එන්නේ 5.75 නේ. මෙහෙම එන්නේ පුතේ. Look at this one. Here 5, 5.25, 5.5, 5.7, 5.5 නේ. 5.5 plus 10.
5.15, sir.
Not 5 point. This is 1, 2, 3,
So
4.
it's 4 point, right?
නෑ මේ පැත්තෙන් ගන්න බෑ පුතේ. You have
So
to
it's
take me. You have to take it from here because once the micrometer screw gauge is closed, this thimble or circular part should be here. Therefore, you cannot take it from here. So this is 0. So 1, 2, 3, 4, 5. Yes, 5. So what are the small counts? Small divisions, man. Look at the small divisions. There are only 4 divisions. 1, 2, 3, 4. There are only 4 divisions within 2 consecutive large divisions. That means 1 division should be equal to 0.25. 0.25. No? Therefore, here 5, 5.25, 5.5. 5.5 is here up to now. 5.5. And then 5.5 plus this one. This one is 10. This one is 10. Not 5.85. 85 in the bag. But 8 එක paid නෑ 7 එක paid නෑ. Actually, I cannot see 7, but I can see 5.5. 5.5 can be seen. And then 5.5 plus discount. And
So is 5.15 is the correct answer?
5.15
15.
නෙමෙයි, not 15. පුතේ 5.25 නෙමෙයි 5.5 නෙමෙයි. Here, in between 2 consecutive marks, so in between 2 consecutive marks, there are 1, 2, 3, 4. .25. This one should be 5.5. 5.5. The other one is not visible. Therefore, I can read up to 5.5. Then the circular reading is 10. Yes, 5.6. Answer should be 5.6. පොඩි කතන්දරයක් තියෙනවානේ. මෙයා වැඩි වෙන්නේ උඩට නෙවෙයි. Yes. සතුලෙම හරි වගේ. Okay. Wait. Okay. Here 10 is here. Now 9, 8, 7 is into the upward direction, while this one is into the downward direction. So this should be 40. මේ question එක මොකක් වැරද්දක් තියෙනවා පුතේ මම පොඩ්ඩක් බලන්න. මෙතන මේ වෙන්න බෑ. I think there's a small problem in this question පුතේ, because if we count more than 10. Actually, there's a questionable thing in this question today, because if we add more than 25, that means suppose if we add more than 20, yes, if we add more than 25, then it will pass 5.75. If it is past 5.75, it cannot be happen. Yeah? So according to this divisions, according to this division, you can clearly see there are 1, 2, 3, 4. 4 subdivisions. 4 subdivision means one subdivision should be equal to 0.25. 0.25. Right? 0.25. Therefore, if the circular, if the circular mark is exceeded that value, that means the other part should be visible. ඒ නිසා මේක එක වෙන්නේ නැහැ. මෙතන මොකක් හරි question එකේ තව date එකක් දීලා තිබ්බත් දැනෙම මේක පොඩ්ඩක් බලන්න. Okay. So no 3.9. It cannot be happen. Actually, initial this one should be at this level. Hey, this thimble and the circular scale should be at this level. Now this one is open this much. This one is open this much initially. So this is the 0 mark. This is the 0 mark. This is the 0 mark of the linear scale. Therefore, this one is shifted from here to here. From here to here. Therefore, definitely the value should be higher than 5. The value should be higher than 5. That is obvious. Hmm. I will check this one, okay? I will check. Then this one, what is the answer? 20,
22.3.
22, 22.33, 22.33, 22.33. Correct.
Yes, sir.
Then this one. One, two, three.
3.315 millimeters.
3.25, 25, what are in 25, 10, 11, 12, 13, 25. That means, sorry, 35. Here, this is 3, not 3.5. This is not 3.5. This is 3.25. 3.25 plus 0. 1, 2, 3. 0.13. 3.25 into 0.13. 3.38. 3.38. Yes. Sorry. Wait a minute. Okay. Look at this one. 10, 20, 10, 15, 20. Hi. In the one class, Okay, look at this one. So we cannot say this one is 3.5 because in between three consecutive marks, there are four number of divisions. Four number of division means that is equal to 0.25. 0.25. Therefore, this one, the measurable count should be equal to 3.25. See, 3.25. And now, sorry. 15, 10. Here 15. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 5 here. Then 1. Yes. Therefore, the answer is 3.38. 3 point. We can take a reading up to 3.25 with it. Up to 3.25 here. Look at this one. 3.25. 3.25 is an Then how many divisions? How many divisions is related?
Excuse me,
I
sir,
don't
isn't the count changing?
Sorry?
Sir, isn't the least count changing in the instrument?
Least count. Least count. But there's no any clue about it.
Sir, because one in the main scale there is 1 divided into 4, so quarter divided by 50, right?
Sorry. Not 0.5. Yes. Therefore, 0.005, you know. Yes. Sorry. I forgot that thing, Buddhi. I forgot that thing, but there's no any clue about the number of divisions. But anyway, we can consider the least count using the linear scale. The linear scale divisions are 0.25. 0.25. Therefore, 0.25 over 50. That means 0.0005. 0. Initial one is 0.01. That one should be divided by 2. That means 0.005. 0.005. 0.005. Therefore, the main scale reading is 3.25. The number of divisions shifted is equal to 13. 13. Yes. 1, 2, 3. 13. So you have to multiply by 30. If I multiply it by 13, 0.65. 0.065. Therefore, 5 here. 1, 3, 3. 3.315. Yes, 3.315. You are correct with it. You are correct. 3.315. Just the three. Yes, to there. Harry, what about others? Did you get my the explanation here? Anita,
Yes, sir.
thank you. Harry, Sandalima,
Yes, sir.
thank you. Then the next question. So what is the answer for this one? Main scale reading, micro scale reading, least count reading. Main scale reading is 0.1. Main scale reading 1 millimeter. 1 millimeter. 1 millimeter. The micro scale reading is 10, 11, 12, 13. 0.13 millimeter. 0.13 millimeter. 1 millimeter plus 0.13 millimeter. So least count. Here least count, we have to take it as 0.01. Therefore, 1.13. Correct? Yeah. The last one is reading is 1.13. Yes. 1, 2, then
Yes, it's 1, 2.
1.12.
Yes, 1, 2, 1, 2, 1, 2, not 1, 3. 1, 2. Then the next one. Main scale reading. 1, 2, 3, 4, 5.
6.5.
Sorry, 6.5. Yes, 6.5. 6.5 millimeters. 6.5. Yes. Micro scale reading
0.32.
0.32. 0.32. Least count is 0.01. Reading is here 0.65. So for 6.5. 6.5 into 0.32. Therefore 6.82. 6.82. How do you? Yes,
Yes.
6.82. Then the next one. 1, 2. Main scale reading is 1, 2, 2 millimeter. Then micro scale reading is
0.44.
yeah 0.44. 0.44 millimeters. Least count is 0.01. 0.01. Therefore, 2 plus 0.44. It means 2.44. Okay. Then this one. So what is the main scale reading, Pute?
10, sir.
10
10.
millimeter. 10. Yes, 10 millimeter. 10 millimeter. Then micro scale reading.
4.
Yes, 0.04. 0.04 millimeters. Therefore, 10.04. 10.04 millimeters. Yes, 10.04 is good. Then the next one. Next one. Main scale reading is 5.5. 5.5. Main scale reading is 5.5. Then other reading is
0.35.
0.35. Therefore, 5.85. 5.85. Okay. That means now we have completed. Okay. That means now we have completed the theory parts of micrometric figures. Now then we have to do spherometer and traveling microscope. There are a lot of instruments today. So do you have any questions up to now, Bhuti? Do you have any questions up to now? Thank you. Others, do you have any questions up to now? Thank you, Bhuti. Then we have to do spherometer, but today I have to stop the class a little bit early today. Therefore, that one will be discussed in our next class. Okay, so you have to read the question, read the spherometer note, then I'm going to describe that one with you. Okay, so I think you don't have any questions, but as a homework, please do the question mentioned in the tutor. And that question is a past-paper question, okay? So please do that one. Okay.
Thank you, sir.
Okay, Pute. Then everyone, good night, Pute. I won.
Good
Thank you,
night,
sir.
sir.
Good
Thank
night.
you, sir.
Tata.